One of the most frustrating things about embedded programming is that although your code compiles, when you put it into the microcontroller, it still doesn't work. But luckily there's a way to find out what's going on. To see some of the solutions that are available, we've been talking to Johan Kraft from Percepio. One of the fascinating things I think about microcontrollers is that they're this little black box and you can't really see inside what's going on. It's quite frustrating to debug some of the challenges, the software challenges that arise.
Yeah.
But that's something that you started to confront many years ago. Tell us about the story behind Percepio and how it came about that you wanted to improve that situation.
Yeah. I was actually working with an industrial edge system, an industrial robotics controller at ABB many years ago. They had some tools for logging and so on, but I got really intrigued by that and kind of visualizing the runtime world of more or less complex embedded systems. And during those years I made some prototype tools that eventually became Percepio Tracealyzer.
Now many people are used to microcontrollers and having some sort of basic debugger. I can do some breakpoints, I can look at the contents of the memory and even flash the parts.
Yeah.
What does Percepio add to that debugging experience for people?
Yeah, we in particularly focus on RTOS-aware tracing and trace visualization. So you can record your system on thread level, API calls, and also do your own custom logging in the application together with that RTOS view. So we provide a lot of lots of different views of the runtime behavior, both memory and CPU load, statistics and stack usage and so on. So it's a tool, kind of visual toolbox for trace-based debugging and profiling.
Now you also support specific types. This requires a real-time operating system running in order that I can find out what task I'm jumping into or leaving, when interrupts occur.
Yeah.
What RTOSs are supported by Percepio?
It's a few. Free RTOS, Zephyr of course, we're here. ThreadX, VxWorks, Cesium, what used to be Micrium. PX5, the new RTOS from Bill Lamy at formerly of Express Logic. VxWorks from Wind River.
So
a few more probably.
A nice wide selection.
Yeah.
Now you've also got a new product which you've been demonstrating here at Embedded Worlds called Percepio Detect. Tell us what that does and how it adds to the standard Percepio software.
Right. Percepio Detect is our solution for CI/CD observability. So when you are doing systematic testing of your system and maybe you get random crashes that are hard to reproduce, or maybe you have some weird anomalies in your system, Percepio Detect can help you both report and detect that, and also drill down into the details so you can really understand what's going on. And it provides a web-based dashboard, so it exposes that to your whole team, so everyone gets the same picture.
And if someone wants to find out a little bit more about Percepio and maybe try it out to see if it fits their application development processes, where should they go?
They should go to percepio.com, and we have self-service evaluations that you can register for and get started in a few minutes.
Super. Well, thanks ever so much for the update. It's very interesting to see a technology that allows us to look deeper into embedded system development. And thanks ever so much.
Thanks for having me.
Store the trace. So for example, if we open up a trace here for the task monitor alert, then it will open up Tracealyzer and show you why the alert was generated. In this case, there's a task that wasn't allowed to run. Let me see if I can just close these ones. So there was a task, or rather there was a task that ran far too much.
Right.
For some reason this task was hogging the CPU.
Yeah.
And that was detected, and we generate an alert with the trace so we can dig into why it actually happened.
Yeah.
And also if you have, for example, a hard fault, the system crashes, and most of the time you wouldn't, if it's in the field, for example, then you wouldn't get any data from it. The user would just report, okay, the device crashes every 10 minutes or something.
Yeah.
I mean, that would be a good case because it would be easy to reproduce, but maybe it's once every week or something.
Yeah.
When I press this button.
On a full moon.
Yeah.